Hi everyone. Now I am going to discuss the second lecture from the units dimensions, measurement and error analysis. Uh, today topic is dimensions and dimensional formula. I am not going to write all the dimensional formulas which are useful for the JEE mains exam and JEE advanced exam that I will write like a I will show like a questions. First of all, what is the meaning of dimension? Dimension of a physical quantity. Physical quantity. Basic definition for this dimension of physical quantity is the power to which fundamental physical quantities fundamental physical quantities need to be raised. Quantities are raised otherwise. Raised is dimension of a physical quantity. Dimension of a physical quantity. For example, if I write that area I can represent in terms of the length and length. So I can write the area as length into length. Length is a fundamental physical quantity and one more length also fundamental physical quantity. Generally, the dimensions of the mass you will represent with m, length you will write like a L, time will represent with dimensions T, temperature, if you write the temperature will represent with K or theta also. Okay. Similarly, if you write the current, electric current will represent with A, ampere, or you can represent with I. Similarly, amount of substance that can be represented in terms of the mole. These are the fundamental quantities. We can see that. Okay. This mass, length, time, temperature, current, amount of substance. I have taken 6 fundamental physical quantities now. Seventh one, luminous intensity is there. Anyway, we are not using directly anywhere. Okay. In our syllabus. Okay. Area, length and length. So area dimension can be written as length is L into L. So you can write it as L square is the dimensional formula of area. Similarly, if I write the speed generally you can write it as distance covered. Speed is distance covered divided by the time taken. Distance is nothing but length only. Time taken is you will write generally time only. Why? Because time is a fundamental physical quantity. So you can write L by T is the dimension of this. So finally you can write it as L T power minus 1 is the dimensional formula of speed. In the same way, if you write the different physical quantities, simply I am writing like a force dimensions. Force can be written as I can write the mass into acceleration. Mass into acceleration. Mass already a fundamental physical quantity, but acceleration is not the fundamental physical quantity. It is a derived physical quantity. We can write mass into acceleration is change in velocity by time. Change in velocity by time. Again, mass into Change in velocity is nothing but displacement divided by the time, whole divided by the time. You can write this as mass into displacement is nothing but length divided by the time square. The final dimensions m l by t square. You can write this as m l t power minus 2. This is the dimensional formula of force. So you can write the dimensional formula for different physical quantities like this. If you know the formula, relation between the different physical quantities, you can write the dimensional formula of any physical quantity you can write. Okay. Now I am not going to extend this one. Just we can refer the any table and we can write the expression between the different physical quantities like this. Okay. Now I am going to give the few fundamental whatever the dimensional formulas are there. I am going to write few things. Okay. Let us consider the which are having the same dimensions. Okay. The quantities having same dimension formulas, same dimensional formula. Some examples I am writing here. If I take the linear momentum and impulse. Linear momentum, you can write it as kg meter by second. Impulse also, it is a change in momentum only. This unit also kg meter by second, or you can write it as Newton second. Both are same meaning only. Both will have the same dimensions as m, l, t power minus 1. These two quantities, whatever the quantities, momentum and impulse is a linear momentum and impulse, will have the same dimensions. Similarly, if I take the, this I am taking like a one point, okay. Next one, if I take the torque and work or energy, any energy, kinetic energy, potential energy, whatever may be the energy. Torque unit is Newton meter. Work or energy, they will also having the Newton meter. If you write the dimension formula of both the things, m l t power minus 2 into l. So the dimension formula of this is m l square t power minus 2. So you can see that dimension formula of torque and work or energy. Any kind of energy is having same dimensions like a ml square t power minus 2. Okay. Next set. You see here, let us consider that velocity gradient. Velocity gradient is nothing but dv divided by the dr, or we can write it as delta v divided by the delta r. This is a change in velocity by change in height. Change in velocity can be written as meter per second, so L by T, divided by the height is L. So we can get the value is 1 by T, that is equal to T power minus 1. The same thing I am going to write one more thing. Velocity gradient and angular velocity. Angular velocity or frequency. If you write what is angular velocity? Angular velocity is nothing but radian per second. So radian will not have any unit. I will give that point also later. Radian is an angle actually that will not have any dimension here. Only second will have the dimension. So you can write it as t power minus 1. Frequency, we can write it as frequency is equal to 1 by time period. We can write it as t power minus 1 is the dimension. Okay. So you can say that one more set is a velocity gradient angular velocity, and frequency. They will have the same dimensions. Like this, different physical quantities are there. We can write the quantities having the different physical quantities having the same dimensions. Okay. Next point. There are some quantities, physical quantities, but they are dimensionless. Dimensionless physical quantities. Dimensionless physical quantities. Dimensionless physical quantities. Which are dimensionless physical quantities are there? For example, I will write the relative density. Relative density is nothing but density of the body by density of water at 4 degrees Celsius. So it is no unit, no dimension, no dimension, nothing but m power 0, L power 0, T power 0. Next one, coefficient of friction. Coefficient of friction. If you take coefficient of friction, mu is equal to, you can write it as frictional force divided by the N. It is unit of Newton, having Newton unit. It is normal force also having Newton is a unit. So Newton by Newton nothing will have. So you can say that no unit, no dimension, no dimension. So you can write m0, L0, T power 0. Refractive index. Refractive index. This refractive index also we are representing it mu or n, that n is equal to speed of light in vacuum divided by the speed of light in medium. The unit actually you can see speed by speed. You can say meter per second by meter per second. No unit, no dimension. No unit, no dimension. So you can write m0, L0, T power 0. This is the these are the some of the physical quantities which does not have the dimension. Okay, a few things only I have written. Remaining whenever we are doing any questions now, we can check like this. Okay. Next, there are some physical quantities having unit but no dimension. There are some physical quantities having unit but no dimension. Which are this? For example, angular displacement. Angular displacement is theta. Theta unit is SI unit is radian. Radian. This radian will not have any dimension. M power 0, L power 0, T power 0 only. Angles will not have any dimensions. Angles will not have any dimensions. Okay. Similarly, earlier also I have not written a few things here. Stress. Stress is stress also you can write change in length by original length, or change in area by original area, or change in volume by original volume. That will also having dimensionless, m power 0, L power 0, T power 0. You can keep that also. Stress also you have to remember. Okay. Now you can see these are the some physical quantities which does not have dimensions. Above cases 1, 2, 3, 4 I have given. Here angular displacement is one of the example here. Okay. Similarly, we can see some relations are there in physics, like a speed of light. Next, velocity, average velocity, all velocities. Speed of light is c is equal to 1 by under root of mu naught into epsilon naught also you can write. You can also use this. And escape velocity Escape velocity we can write under root of 2gm divided by the r, or root over 2gr, where g is the gravitational constant, m is the mass, r is the radius, g is the acceleration due to gravity, r is the radius. Okay, orbital velocity VO is equal to, we can write G capital M by R, or we can write it as G into R on surface of the earth. So these relations also, if you see, all are having same dimensions. That dimension is, we can write it as L t power minus 1. Some relations regularly what they are, they can ask in exam. I have written. Okay. One more thing, time related dimensions. Time is having a dimension of t. Which quantities can have these time dimensions? I am writing now. Suppose say in RC circuits. In RC circuits, we have got like a RC value is equal to, you can write as tau is equal to R into C is there. That RC is also having dimension is t only. Now in LR circuits, inductor and resistor circuits, we can write tau is equal to L divided by the R. Okay, so we can write it as L by R also having same dimension as T. Okay, now like this different physical quantities we can write. Next one, frequency having dimension is t power minus 1. Here we can write it as angular frequency t power minus 1 only. Angular velocity also we can write t power minus 1 only dimensions. Next one, decay constant can be written as actually lambda, unit is second minus 1. Okay, so we can write it as t power minus 1 is the dimensional formula. Okay, like this there are the different physical quantities are there having same dimensions that I have written here. Few points I have written earlier also. I have written few points are having same dimensions. Okay, you can check that. Okay, next one, note, dimensional formulas no not valid for all the cases. Some quantities are having like some quantities, some numbers, some mathematical expressions, they are not having any dimensions. Okay, I am writing numbers like 1 2 3 numbers are there, no, that numbers. Angles like 30 degrees or 90 degrees, pi radian, these are like pi by 3 radians, whatever 2 pi by 3, these radians will not have any dimensions. Trigonometric expressions, trigonometric expressions is nothing but sine theta. This theta is dimensionless. You can write m power 0, l power 0, t power 0. Okay. Similarly, if I write the sine of ax plus bt, now dimension of ax plus bt is m power 0, l power 0, t power 0. Observe this carefully, like this. Trigonometric expressions, logarithmic functions, like log of, if you take that like a ax plus b is given to you. This ax plus b, dimension of ax plus b is m power 0, l power 0, t power 0. Here x may have dimensions, a may have dimensions, b may have dimensions. Understand that in this case also, a may have, x may have dimensions, b may have dimensions, t may have dimensions. But this ax plus bt is dimensionless. Similarly, later I will tell in principle of homogeneity, ax and bt also will not have any dimensions. Separately, a may have dimensions, separately x may have dimensions. Here also separately a may have dimensions, separately x may have dimensions, separately b may have dimensions, but a x term is there, no, that may not have any dimension. Similarly, b term, if I write m0 l0 t0 will write later, we will see now. Okay, in this case now ax is dimensionless, b is dimensionless, but a will have dimension, x will have dimension. Okay, next one, differential functions, differential and integral functions will not have dimensions, are dimensionless, m0 l0 t0 will have dimensionless, meaning exponential functions also, exponential functions, whatever mathematical functions are there, they are dimensionless, they are dimensionless. You let the dimension meaning is m power 0, l power 0, t power 0. By keep in your mind like this, or our mind, these all points, we are going to write the some physical quantities dimensional formulas, how it will be there, I am going to show you now. Okay, again I am telling you just what is the meaning of dimensions. The power to which the fundamental physical quantities are raised is dimension of any physical quantity. Generally we are writing in terms of the fundamental physical quantities are there, no? Mass, length, time, temperature, current, amount of substance, and luminous intensity. We are not writing here luminous intensity. Remaining values I have written. First we have to know the relation between the different physical quantities, and we have to express that physical quantities into the fundamental physical quantities. Then you have to write the relation between the different physical quantities in terms of the MLT form. Okay, I am going to do the some questions now. You can see. Observe this carefully. As per the question, let this is epsilon naught denote the dimensional formula of the permittivity of vacuum. If m is the mass, l is the length, t is the time, and a is the electric current, then what is the dimensional formula for permittivity in vacuum? So to write the dimensional formula for this, first of all you should have the expression for the dimensional formula of the relation for the permittivity. As you know, Coulomb's law, in Coulomb's law, we have written force between two charges is 1 by 4 pi epsilon naught q1 q2. I am writing like a q square divided by the r square. From this you can write epsilon naught is equal to q square divided by the 4 pi f r square. As 4 pi is a number, no dimension. It will not have any dimension. Q will have dimension, fr will have dimension. I am writing now. Dimension formula for charge q. You can write that charge is nothing but current into time taken. Current is the fundamental quantity A, and dimension is A, and time is the fundamental physical quantity. You can write AT is the dimension of charge. Next, dimension of force. Force can be written as, you know that already, force dimension formula is ml t power minus 2. You can write dimension of r. Dimension of r is length only, L. You will write. You write this dimension of epsilon naught is, I am writing here, A t. So q square is there, so you can write a square t square divided by the ml t power minus 2. L square is there, r square is there, so you can write L square. Now if you write this, m only denominator is there, so you can write it as m power minus 1. L and L, so you can write L cube. If it go up, L power minus 3. T square is there, and here t power minus 2 is there, so you can write t power 2 plus 2, so you can write 4 a square. So this is the dimensional formula of permittivity. So my suggestion is, you cannot remember this actually. Sometimes you may try to remember, but There are so many fundamental physical quantities. So whenever you are trying to remember these all, you may forget. My suggestion is you try to make a expression. So not only this formula, whichever formula is available for you for the epsilon naught, that we can apply. So as per this, we got like a m power minus 1, L power minus 3, T power 4, A square. You can see the second option is matching this m power minus 1, L power minus 3, T to the power of 4 and A to the power of 2. So this is the dimensional formula of permittivity of vacuum. Okay. Same thing, I am going to proceed for the further thing. Let us consider in the second question, like in 2019 mains, they have asked this one. In the formula, x is equal to 5yz square, x and z have the dimensions of the capacitance and magnetic field respectively. What are the dimensions of y in SI units? See, I am taking like different kind of questions like which you may feel difficulty while writing the dimensional formulas. Okay, you can see in this question, what is the dimensional formula for capacitance? Dimension formula for capacitance. Capacitance. We can see first how to write the capacitance. You have like a capacitance C is equal to charge by voltage or potential difference. Okay, charge is nothing but you can write current into time taken divided by the voltage is nothing but joule means work done by you can write it as work by charge, work done per unit charge is there, no, that. So we can write the value is C is equal to, I can write this is suppose if you write this Q divided by the work done divided by the Q is there, no. So you can write it as Q square divided by the work done. What the dimension formula? Already I have written I into T, you can write now. So if I write this value as I square into T square divided by the work done. Okay. So finally dimension formula of C can be written as A square, current is I square is that is A square is the dimensional formula for current. T square, time is T square. Work is nothing but M L square T power minus 2. If I write this whole value, M power minus 1, L power minus 2, T power 4, A square. This is my capacitance dimensional formula. Similarly, magnetic field, we need dimension of magnetic field. Magnetic field. What formulas we are having for the magnetic field? Magnetic field, you can write it as general formula. Magnetic field is nothing but force per unit pole strength. Unit pole strength. If you have any formula, you can write any relation, whichever is you remember, that we can write. F is equal to BQ is there, no, that also you can write. Okay, force per unit length. Force is nothing but Newton. Pole strength unit is ampere meter. I am writing dimension of B can be written as dimension of B is Newton is ML T power minus 2 divided by the ampere is ampere only and meter is L. So L and L get cancelled. Finally, I will get the M T power minus 2 A power minus 1. This is my dimension of B. You see the question, x is equal to 5yz square. Here z is the actually x is the dimension of capacitance and z is the magnetic field dimension. We need to calculate y value. I am writing dimension of x is equal to, as number 5 is dimension, this is dimensionless. Dimensionless. Okay. So you can write the dimension of y into dimension of z, z square. What is the dimension of z square here? Dimension of z square. I am writing here x value is m power minus 1, as we have got this value here, m power minus 1, L power minus 2, T power 4, A square is equal to dimension of y into dimension of z square. Z square means we have to square it. M square t power minus 4 a power minus 2. Okay. Now dimension of y is equal to m power minus 1 l power minus 2 t power 4 a square whole divided by the m square t to the power of minus 4 a to the power of minus 2. Now if you bring this m value up, it will become m power minus 3. L power only one term is there, L power minus 2. If you take the t power minus 4 up, you can get the t power 8. A power minus 2 if it go up, a to the power of 4. This is the dimension of y. You see anywhere is there m power minus 3, L power minus 2, t power 8, a power 4. You can observe this fourth option is correct option. Okay. I see. Actually, I also don't. I will not remember these all dimensions, but basic dimensions are there. No, length, area, volume, like force, acceleration, energy. Few fundamental physical quantities are there. No, are derived physical quantities that we have to remember. Understand that by knowing the any relation between the different physical quantities, you can write the dimensional formula of any kind of physical any kind of derived physical quantity. You can write the dimensional formula. Okay. Next one, you observe this. A quantity f is given by f is equal to h c to the power of 5 by g under root is there, where c is the speed of light, g is a universal gravitational constant, h is the Planck's constant. Dimension of f is equal to which of the following you may get. Okay. Dimension of f, they have not given what is the quantity name of f here, that you need to calculate here. First, what is the dimension of h? Dimension of Planck's constant. Planck's constant. See, you can see Planck's constant h is equal to energy by frequency. From the Planck's formula is there, Planck's theory, E is equal to h nu. From there I am writing frequency. Energy is nothing but ml square t power minus 2. Frequency is t power minus 1. So finally, the dimension of h can be written as, I am writing finally, dimension of h is m l square t power minus 1. This is my dimension formula, Planck's constant. Next, dimension of speed of light. Speed of light. If I write the dimension of speed of light, c is l t power minus 1. It is a speed only, just you can write the l t power minus 1. Next, dimensional formula for g, universal gravitational constant. First, you should know what is the formula for this. You have like a, before writing this, just I am writing the expression. We have f is equal to g m1 m2, that I am writing m square divided by the r square. So from this, we can write the g is equal to f r square divided by the m square. Now I am going to write the relations here. Dimension of g can be written as, dimension of g is equal to f is nothing but m l t power minus 2, and this is distance square, that is l square, by m square. Mass is mass square, we can write as m square. So finally, if I bring this m square up, you will get the m power minus 1, and l is there, l power 1, here l square, that is l cube t power minus 2. This is the dimensional formula of g. Okay. I have written h, c and 5. Three values I have written. Now you will follow this. Dimension of f is equal to under root of, first quantity is h. H I am writing m l square t power minus 1 into c to the power of 5 they are telling. So you can see c to the power of 5. What is c to the power of 5? We can write it as l to the power of 5 t to the power of minus 5 whole divided by the g. They are writing g. G value I am writing m power minus 1, m power minus 1, l power 3, t power minus 2. Just observe this. you will get like a under root of, if m is going up, you can write it as m square, L square, and you can see down L cube is there, here L to the power of 5 also there, nothing but L to the power of 7 minus 3. Next one, T to the power of minus 1 minus 5 minus 6 plus 2 is there. Now if you write the value is m square L to the power of 4 T to the power of minus 4. You can write the value is m L square T power minus 2 whole square under root. So square and root get cancelled. Finally, you will get the m L square T power minus 2. This is the dimension of F. So according to this, we can say that this is a work or energy. If it torque is there, or torque also. Okay, you see options. Energy is there in first option only, you can take the first option. It is not the area, it is not the volume, it is not the momentum. Area dimension is L square, volume dimension is L cube, momentum dimension is kg meter per second, so you can write ml t power minus 1. These are the dimension formulas. Okay, so next question. You see a dimensional formula for thermal conductivity is, how to write the thermal? See, I have not remembered any dimensions except a few things like a force, energy and all. Okay, you just observe this. Thermal conductivity. First of all, you should have the expression. What is thermal conductivity? You have studied like a Fourier's theory in heat transfer of conduction. We can see dq divided by the dt is equal to negative of Ka into dt divided by the dx. This is the energy by time. Energy by time. Anyway, negative term is not required. K, I am taking instead of taking K, actually in options also there is a K is there. Whatever thermal conductivity is there, no, that I am taking like a something like a big K. Okay. So you can say this big K we don't know, into area. Area is actually everyone knows that area only. This is temperature divided by the length. Okay. You just observe this. How to write dimension of K? Dimension of thermal conductivity. This is only thermal conductivity. Thermal conductivity can be written as energy divided by the time. If you bring this one is this side into length, you will write. Next, area, you will bring area down, temperature also down. If you remember the directly dimensional formula unit, you can write from there also. Okay, so area is nothing but length into length. Now one length and length get cancelled. So finally you can write it as energy by time into length into temperature. Energy is m L square T power minus 2. Dimension formula for energy is ml square T power minus 2 divided by time is T, length is L, temperature is K. As per the question, you can see here K they are representing. We can represent with theta also. Okay. Now you can see L square and L one time get cancelled, and T remaining you will write m L T power minus 2 minus 1 K power minus 1. So finally you can write it as m L T power minus 3 K power minus 1. This is my dimensional formula of thermal conductivity. So you can see which option is possibility is there, m L T power minus 3 and K power minus 1. m L T power minus 3 K power minus 1. Second option is the correct option. Okay. Next one. Now you can see there is a, actually in this chapter, if you see the trend of the JEE mains exam, mostly they are giving like a list 1, list 2 questions only. Okay. In 2021, 22, 23 and 24 also, even if you see that, they have asked like a just list 1 and list 2 which is matching. Okay, one of the question I have taken, you can see in 2021. Planck's constant. Earlier I have written already Planck's constant dimension formula. Okay, anyway, if you want, we can write again Planck's constant. Planck's constant H is equal to energy by frequency. Energy by frequency. M L square T power minus 2 divided by the T power minus 1. We'll get ml square T power minus 1. Which one is satisfying the ml square T power minus 1? We can see ml square T power minus 1. In options, only 1, 2 is there. So this is only option. If you want, you can check the remaining thing also. Kinetic energy, ml square T power minus 2, ml square T power minus 2, 3, it is matching. Electric potential you can write it as potential is work done per unit charge. Work is nothing but ml square T power minus 2. Charge is nothing but current into time taken. We can write the A into T. If you can write ml square T power minus 3 A power minus 1. So where this option is there, instead of A they have given I. We can see I they have given R. We can write ml square T power minus 3 I power minus 1. Okay, we can represent with I also. So potential is fourth option. We can see fourth option. Next, linear momentum. Linear momentum is, we know that kg meter per second. So you can see kg meter per second. So second option is the correct option. Okay, next one. Next, list 1 and list 2 questions. Capacitance. Earlier I have given capacitance C is equal to charge by voltage. Not only this, half CV square also you can write energy is equal to half CV square. Okay, current into 1 minute. So you can write the charge is Q divided by the voltage is W by Q, work done by charge. Q square divided by the W, work done. So you can write it as C. Why I am writing every time? No, I am not copying from back side. Reason is in exam you don't know. That's why I am writing again. Okay, C is equal to actually you can write it as I square into T square, current into T. D is nothing but current into time taken. Okay, A square into T square, and work done is equal to M L square T power minus 2. You can write the dimension of this value is M power minus 1 and L square T power 4 A square. You see which of the following is matching that. M power minus 1. M power minus 1 here is there. L square, sorry, L power minus 2 is here. L power minus 2. Next T to the power of 4 and A square. So capacitance is matching with 3. So there are the two options are there. Now if you check the next question, automatically you will get permittivity. Epsilon naught. You have like F is equal to next one, F is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. I am writing Q square by R square. So from this epsilon naught is equal to Q square, epsilon naught is equal to, you can write as Q square divided by the 4 pi into F into R square is there. Anyway 4 pi is dimensionless. You can write the this is I into T, I square into T square you can write. Remaining usually you know that. Dimension of this epsilon naught can be written as A square T square divided by M L T power minus 2 L square. Now you can write the M power minus 1. Here L is there and L square is there. So you can write L power minus 3. T power square is there, here down T power minus 2 is there. So T to the power of 4 and A square. This is M power minus 1, L power minus 3, T to the power of 4 and A square. So you can see second option is matching with the second one only. Second option is matching with second one only. So second option is the correct option. Okay, remaining also I will check. Permeability of free space. F is equal to, magnetic field B is equal to, you have like a mu naught by 4 pi by itself I am writing. I dl sin theta divided by the R square. B is equal to mu naught by 4 pi into ideal sin theta by r square. So I am remembering this, that's why I have written. If you want, we can write different things. C is equal to 1 by root over mu naught epsilon naught is there. That also we can write. Okay. What is a magnetic field? Force by pole strength. Force by pole strength. Force is nothing but, pole strength is nothing but, you can write as ampere meter is the unit. Okay. This is equal to mu naught and I value is ampere, dl is meter divided by the meter square. I am writing force is ml t power minus 2 ampere length is equal to mu naught dimension of mu naught into dimension of A is A only. So m and m get cancelled. So we can get the down is L will get. Here L. From this L and L get cancelled. Dimension of mu naught is equal to m L t power minus 2 divided by the A square. That is equal to m L t power minus 2 A power minus 2. Observe this carefully. Which of the following is matching this? M L t power minus 2 ml t power minus 2 a power minus 2. So you can match with the fourth one. Last one, electric field E. What is electric field? Actually, electric field we can write as dimension of electric field. Electric field E is equal to force per unit charge. Force is ml t power minus 2. This one is current into time taken. We can write A into T. So we can write m L t power minus 3 A power minus 1. Observe this carefully. ml t power minus 3 A power minus 1. So this option is matching. Already answer means in exam you got you will get directly. Okay. In first two if you check no A and B, then only you will get. Okay. Now I am going to do the next one. See again, match list 1 with the list 2. Magnetic induction. What is a magnetic induction? Magnetic induction means B only. Okay. If you take the B, what formulas we are having? I can write the B value is different formulas also. Earlier I have written already magnetic induction. F is equal to BQV is there. From this B is equal to much? F divided by the Q into V also we can write, or we can write force per pole strength also we can write. Pole strength or pole strength. Anyway, I have written in terms of the pole strength earlier. Now I will write in terms of the F and QV. You check once. B can be written as force is nothing but ml t power minus 2. Charge is nothing but ampere into time. And velocity is L t power minus 1. If I write the value is m, L and L get cancelled. So you can write the value is t power minus 2 and t power down also t and t get cancelled. T power minus 2 A power minus 1 is there. This is my B. Okay. Dimension of B can be written as m t power minus 2 A power minus 1. T power, so we can say t power minus 2 A power minus 1. Okay. Next one. Magnetic flux. What is a magnetic flux? Magnetic flux is nothing but flux is equal to B into area. I am not writing cos theta and all, just B into area. So magnetic field already you got the m t power minus 2 A power minus 1. Area is L square. Okay, so finally m L square t power minus 2 A power minus 1. This is the dimension of magnetic flux. I am writing phi suffix B. Where is ml square t power minus 2 A power minus 1? You can check the second one. Okay, sorry, second one is matching with the first one. B is matching with 1. So you can take the first fourth option. If you want, you can check the remaining also. Magnetic permeability. What is a magnetic permeability? I have written so many times this mu naught value. Mu naught actually you can write it as earlier also I have written. If you want, you can write again. B is equal to mu naught divided by the 4 pi into I dl sin theta divided by the r square. Already B value I got like a m t power minus 2 A power minus 1 in this question. Okay. that is equal to dimension of mu naught into I is a and L divided by the dl is L square. So we can see that L and L square get cancelled. Remaining value dimension of mu naught is equal to the m t minus 2 a power minus 1 into L. Here L is that L divided by the a. So if I write the value is m L t power minus 2 a power minus 2. Just check that m L t power minus 2 a power minus 2. This is matching with the fourth. Anyway, you got that. Magnetization. What is the dimension formula of magnetization? Magnetization means intensity of magnetization is there I. Okay, that is m means magnetic moment m divided by the volume v. R. One more thing is there. Sorry, I is a magnetizing field. Okay, intensity of magnetization is there H. That H can be written as B divided by the mu naught, magnetic field by the B naught. Both will have the same unit ampere per meter. You may have studied this one in magnetism and matter, like properties of the magnetic materials are there, no, dia, para, ferro. There you may get these elements. Okay, ampere per meter. So the dimension of HRI, you can write it as ampere is A, meter is ampere per meter, no, so L. So finally you can get the L power minus 1 a power 1. So like this, any option is there, you can check that. M power 0, you can see m power 0, L power minus 1, and this second option is correct. Here m term is not there, that's why you write m power 0, L power minus 1 a. This is the dimensional formula of magnetization or magnetizing field. Intensity of magnetization or magnetizing field, both you can write. Next one, which of the following is not a dimensionless quantity? Not dimensionless quantity. You see a quality factor or Q factor. Q factor you can write as omega naught L divided by the R. Omega naught is nothing but resonance frequency. Any frequency unit is 1 by second only. Second minus 1 is a unit. L by R. Earlier I have given time is nothing but L by R. Okay. Omega naught will have second minus 1. That is here second is a unit of the L by R. So you can second minus 1 into second. Or dimension formula if write t power minus 1 into t. So finally you will get the m0, L0, t0. This dimension quality factor is dimensionless quantity. Okay. Next one, power factor. Power factor, you can write it as P average is equal to VRMS, IRMS, cos phi is that. Cos phi is the power factor. It is angle. Not angle actually, it is a number. This number you may get like a cos, suppose phi value is 0, cos 0 is 1. Phi value is 30 degrees, we can write it as root 3 by 2. If phi value is equal to 60 degrees, we will get the cos phi value is 1 by 2. So it is a number, so it is a dimensionless quantity. M0, L0, T0. This is also dimensionless quantity only. Permeability in free space. So till now you got the permeability in free space. Mu actually just now earlier also I have given B is equal to mu naught by 4 pi into I into dl divided by the R square. So from this you can write mu naught dimension is mu naught can be written as in terms of the B naught divided by B naught R square divided by the I into dl. So having dimensions, it is having dimensions, and we have proved till now, we can see that it is having some dimensions. So what they are asking, which is not a dimensionless quantity. So third option is the correct option. Okay. Next one, relative permeability mu r. So what is the relative permeability? Mu r is equal to mu mu medium divided by the mu naught. Okay, it is actually permeability in medium and permeability in free space, so it is no unit, no dimension. So unit is dimension formula is m0 l0 t0. So it is also having dimensionless quantity. Earlier I have given some of the dimensionless quantity. No, I gave only few things there. Why? Because I have taken remaining as a question what JEE means they have asked. Okay, so according to this question, which is not dimensionless quantity? Permeability. So answer is 3. Okay, next one more question in 2020 from the 2021 list 1 and list 2. Torque, you know that torque is having unit is Newton meter, ml t power minus 2 into L. So you can add ml square t power minus 2. Where ml square t power minus 2 is there, you can see torque is matching with the third one. There are the two options are there. A is matching with the 3. Okay, impulse, it is nothing but having unit is kg meter per second. You can add ml by t, that is equal to ml t power minus 1. So m is impulse is having like a ml t power minus 1. We can say B is matching with the in first option 4, and third option B is matching with first. So we can say that third option is the correct option. Next, tension is nothing but force only. So you can add ml t power minus 2. So force is ml t power minus 2. Next, surface tension. Surface tension, you can write it as S is equal to force by length. Force per unit length actually. Force per unit length of the free surface. You can write it as ml t power minus 2 divided by the length. So L and L get cancelled, m t power minus 2. This is the dimension of surface tension. You can write m t power minus 2. So anyway, it is matching here. I am going to give the one point here. Here only you can see a note. Spring constant K is equal to force per unit extension, and surface tension S is equal to force per unit length. Both are having like a Newton per meter only unit, and dimension formula is m t power minus 2. Both are having same unit and same dimension. One more thing also I forgot to mention earlier. Planck's constant H is equal to energy by frequency, that is ml square t power minus 2 divided by the t power minus 1. You will get ml square t power minus 1. Similarly, angular momentum. This angular momentum L is equal to, we can write it as m into Vr, linear momentum into perpendicular distance. You can add m L t power minus 1 into L, that is equal to m L square t power minus 1. You can observe this, both are having same dimensions. So Planck's constant and angular momentum is same dimension. Spring constant and surface tension also will have the same dimensions. You kindly observe that. Next one, in 2022 JEE means they have asked that identify the pair of physical quantities which have different dimensions. You can observe that. Actually today you can observe that I am not explaining the principle of homogeneity, how to write the relation between the different physical quantity relations like a formula type. I am not writing that. Just I am using only dimension formulas only. In this lecture I am giving only dimension formulas. Okay, wave number and Rydberg constant. You observe this, wave wave number is nothing but k is equal to 2 pi by lambda. The unit of this, if you write that, unit is meter minus 1. Dimension formula is L power minus 1. Next, Rydberg constant. Rydberg's constant. You know that R is equal to actually 1 by lambda, proportional to 1 by lambda. So you can say that unit is meter minus 1, L minus 1. So which of the following have same dimensions? So first question only, first option only correct option. Okay. Second option you check. Stress and coefficient of elasticity. Stress. Stress is nothing but force by unit area. ml t power minus 2 divided by the L square. You can write it as ml power minus 1 t power minus 2. ml power minus 1 t power minus 2. Next, coefficient of elasticity. Okay, they are asking different physical quantity now. First one is having same dimensions. You observe this kindly. Different dimensions. They are having same dimensions. Wave number and Rydberg constant same. Stress and coefficient of elasticity. Coefficient of elasticity, we can write it as E is equal to stress by strain. Stress is m L power minus 1 t power minus, just above I have written. Strain is no dimension, m power 0 L power 0 t power 0. So you can add m L power minus 1 t power minus 2, same dimensions. So stress and coefficient of elasticity is same. Coercivity and magnetization. What is the meaning of coercivity and magnetization? Coercivity is nothing but actually if you see that I and H graph is there, no? That I and H graph, if you see that, somewhere you will see that graph is going like this and coming here. Wherever the H value is 0, I is non-zero term is there, no? That is coercivity. Nothing but I only. I unit is ampere per meter. So you can write it as ampere into L power minus 1 is the dimension. Next, coercivity is written. Magnetization. What is the meaning of magnetization? Magnetization also, you can say that same thing. You can write it as H only. That also intensity of magnetization you can write. Same I only. Okay, same I here, it is not the magnetic field. Or otherwise if they ask like H also having ampere per meter only, you can add A L power minus 1, same dimension. Specific heat capacity and latent heat. What is specific heat capacity? Specific heat capacity means Q is equal to mc into delta T is it, change in temperature. This is change in temperature. Q is heat energy. M is mass. C is specific heat capacity. Specific heat capacity. From this, C is equal to Q divided by the M into delta T. We can write dimension formula is M L square T power minus 2 divided by the mass is M, delta T is K Kelvin. We can write the value is L square T power minus 2 K power minus 1. This is the dimensional formula for specific heat. Okay. Next, latent heat. Latent heat can be written as Q is equal to mass into L. Okay. Latent heat can be written as latent heat is equal to Q divided by the M. M L square T power minus 2 is the dimensional formula for energy by mass is M. So you can write L square T power minus 2. If you see the dimensional formula of latent heat is L square T power minus 2. Dimensional formula of specific heat capacity is L square T power minus 2 K power minus 1. So this option is different from the above three. So different dimensions. Specific heat capacity, latent heat both are having different dimensions. I am writing here different dimensions. Okay. So option 4. Next one. Identify the pair of physical quantities that have the same dimensions. Again, they are asking questions like a same dimensions. Now you see velocity gradient. Velocity gradient. This velocity gradient you can write it as dv divided by the dr. Unit is meter per second divided by the meter. So finally you will get second minus 1. Second minus 1 dimension is t power minus 1. Next, decay constant. Decay constant. Decay constant is per second only. So SI unit is second minus 1, t power minus 1. So first option is they are asking same dimension only. First option here correct only. Next, Wien's constant and Stefan's constant. What is Wien's constant and Stefan's constant? You can write the Wien's displacement law lambda maximum into t is equal to b. This is a Wien's constant. Wien's constant. You can write the lambda maximum unit is L, meter only, length. It is K, temperature. So you can write the dimension of B is Lk. Next, Stefan's constant. We have like a power is equal to EA sigma T to the power of 4. In radiation, E transfer chapter, radiation you have studied there. This is joule per second. No unit emissivity is a number only, and A is actually meter square. Sigma T to the power of 4 is Kelvin to the power of 4. You can write the sigma unit is joule per meter square second Kelvin to the power of 4. You can write m L square T power minus 2 divided by the L square, second is T, and Kelvin to the power of 4 is K4. L square get cancel. M T power minus 3 K to the power of minus 4. This is the dimensional formula of Stefan's constant. So this is wrong. They are not having same dimensions. So you can see here B is this and K is this. Both are not having same dimensions. Angular frequency and angular momentum. What is angular frequency? Angular frequency is nothing but second minus 1, t power minus 1 it will have the dimensional formula. Angular momentum you can write it as L is equal to m into VR. So m L t power minus 1 into L. So finally you will get the m L square t power minus 1. So it is also not having same dimensions. Wave number and Avogadro number. Wave number you can write as k is equal to 2 pi by lambda. Nothing but meter inverse is the SI unit. Dimensional formula is L power minus 1. Next, Avogadro number. You can see Avogadro number. Avogadro number is having Na is equal to 6.023 into 10 power 23 per mole. So mole is mole power minus 1. It is a dimensional formula of Avogadro number. So now from this we can write it as per mole here. That's why 1 by mole I am writing. Mole power minus 1. So both are not having same dimensions. So which of the following is correct option? First option is the correct option. You see a new terms we are getting. Avogadro number. Avogadro number is mole power minus 1. Don't write number. Okay. Dimension of mutual inductance. What is the dimensional formula for the mutual inductance? We are having like a flux is equal to mutual inductance into I. So mutual inductance is equal to magnetic flux divided by the current. Magnetic flux is nothing but magnetic field into area divided by the current. Magnetic field earlier I have written B is equal to F divided by the Q into V. So you can write it as I is nothing but current into time taken. Okay. So you can write it as M L T power minus 2 whole divided by the Q is nothing but ampere into time. Velocity is L T power minus 1. So we can write it as m, l and l get cancel, t power here t power minus and this get cancel, t power minus 2, a power minus 1, m t power minus 2 and a power minus 1 is there. You also check properly. Next one, what is the area and the current is there, no, that I am writing. M t power minus 2 a power minus 1, area is l square, this is the area l square, divided by the current is ampere. So you can write m l square t power minus 2 a power minus 2. So observe this, m l square t power minus 2 a power minus 2, third option is there. Write carefully. Actually actually we cannot remember that magnetic field and magnetic flux, everything you cannot remember, no. That's why every time I am writing, you can also check that how I am writing. Okay. Next one, if L, C and R are the self-inductance, capacitance and resistance respectively, which of the following does not have the dimension of time? See, earlier I have given what is the time. Tau is equal to, we can write it as R into C. So it is a dimension of time only. Okay. This is a time dimension. Time dimensions. Tau is equal to RC, and we can write it as tau is equal to L by R. This is also correct only. And we can write omega is equal to 1 by root LC is there. So from this we can write time period T is equal to 2 pi by omega. We can write 2 pi root LC. In LC oscillation you got like this. So the dimension of root LC, dimension of root LC is same as time t. So this is also correct only. If you write L by C, inductance and capacitance, so they are not having the dimension of this. If you want, you can see that dimension of L, flux is equal to Li. So you can write L is equal to flux divided by the current. Flux is nothing but B into area by current. So just now I have written that. If you want, you can check that mutual inductance is that. So mutual inductance is ml square t power minus 2 a power minus 2 is there, no. Same manner we will get. So just now I have written. You can also try that. Okay. I'm seeing from here. Just you can try in exam. Okay. Ml square t power minus 2, ml square t power minus 2 a power minus 2, ml square t power minus 2 a power minus 2. That is a L. And C, what is C value? That also I have written earlier. Q by V, that is Q divided by the work by this. Q square is nothing but a square t square divided by the m l square t power minus 2. You can write it as m power minus 1, l power minus 2 and t power 4, a power 2 is there. If you write L divided by the C value, you can get the m l square t power minus 2 a power minus 2 whole divided by the m power minus 1 l power minus 2 t to the power of 4 a square. You will get the finally m square l to the power of 4 t to the power of minus 6 a to the power of minus 4. This is the L by C value. You can see it is not time dimension. Not time dimension. It is not time dimension. So which of the following is correct option? So option 4 is the correct option. Okay. Remaining you can remove this. Option 4. Option 4 does not have the dimension of time. Okay. Next one. They have asked, sometimes they are asking assertion reason type, statement type questions also they will ask. You can see what kind of question they have asked here. Product of pressure and time t has the same dimension as the coefficient of viscosity. Now what is the coefficient of viscosity? You can write force is equal to negative of eta into area into velocity gradient dv divided by the dx. We can see eta is equal to f divided by the area, that is equal to pressure, divided by the dv divided by the dx. Okay, this is pressure, divided by the, this value will get the second minus 1 only, time will get. Okay, 1 by time you will get, 1 by time. Earlier also I have given, if you want you can refer this. This is like a meter per second divided by the meter. Meter get cancelled, we'll get the second minus 1 only. That's why I have written time. So dimension of this eta is pressure into time type relation is there. Pressure is nothing but Pascal second. It is the SI unit of eta. What is Pascal? Actually, force by area is a pressure. Pressure is force by area. ml t power minus 2 divided by the L square. We can write ml power minus 1 t power minus 2. Eta value is equal to how much now? ml power minus 1 t power minus 2 into t. We'll get L power minus 1 t power minus 1. This is the dimension formula of this. Anyway, they are not asking that. Just I am writing the what is the dimensional formula of eta. Okay. Product of the pressure into time is what here? Pressure into time. You can see product of pressure into time is coefficient of viscosity. Correct only. Coefficient of viscosity can be written as force by velocity gradient. You just observe that coefficient of viscosity is force by area, force divided by the area into velocity gradient. Velocity gradient dv divided by the dx is that. Okay. So if you see this, this reason is incorrect. So which option is correct now? A is true, but R is false. I am giving different questions from different JEE mains questions. Similarly, JEE advanced also I have taken. We can see, okay. Assertion, time period of oscillation of a liquid drop depends on the surface tension S. If density of the liquid is rho, radius of the drop is r, then time, how we are writing? K is a dimensionless quantity. I am writing, see, density. Dimension of density, if you write that, dimension of density I am writing, as it is kg per meter cube is a mass per unit volume. So you can write m L power minus 3 is the dimension formula for this. Next, radius r. Radius r is having dimensional. Surface tension. Surface tension. We can write S is equal to force by length. We can write it as m L t power minus 2 divided by the L. So you can write m t power minus 2. You check that under root of rho r cube divided by the s to the power of 3 by 2, dimension of this I am writing now. If I write the dimension of this as density is m L power minus 3 and L cube whole divided by the surface tension m t power minus 2 whole to the power of 3 by 2. If you check this, L power minus 3 and plus 3 get cancelled. So m divided by the m power 3 by 2 t power minus 3 under root. You can write under root of m 1 minus 3 by 2 t power 3. You will get under root of m power minus 1 by 3 t cube. If you see, it is not equal to time. Not equal to time dimension I am writing here. Not equal to time dimension. Okay. So whatever the relation they have told, no, the time period of oscillation t is equal to some dimensionless constant into rho r cube by s to the power of 3 by 2. This assertion is wrong. So where assertion is wrong is there? Fourth option, A is false. But you will see whether reason is correct or wrong. Using dimensional analysis, we get RHS having the different dimension than that of the time period. Obviously, we are having like a right side, this under root of rho r cube by s to the power of 3 by 2 is having different dimensions. So R is true and A is false. Okay, option 4. Next one, dimension of b square by mu naught will be. You might have studied like energy density. Energy density, average energy density of electromagnetic wave is b square divided by the 2 mu naught. That is also half into epsilon naught into E naught square. Or energy density of magnetic field. Energy density in magnetic field. You can write it as u is nothing but b square divided by the 2 mu naught. Anyway, 2 is a number, it will not have any dimension. What is the meaning of energy density? Every time I am writing energy density here. Energy density is nothing but energy per unit volume. Energy per unit volume. What is energy? ml square t power minus 2 divided by the L cube. So we'll get ml power minus 1 t power minus 2. This is the dimension formula of energy density. Okay, of epsilon naught e naught square or b square by 2 mu naught. So are having same dimension, ml power minus 1 t power minus 2. In this, third option is the correct option, energy density. Okay, next one. Here I am going to tell one thing here. Energy density, note, energy density is energy by volume. That dimension is ml power minus 1 t power minus 2. Next, pressure. If you write pressure, P is equal to force by area. ml t power minus 2 divided by the L square. That is ml power minus 1 t power minus 2. Observe this carefully. Energy density and pressure is pressure both are having same dimensions. Okay, energy density and pressure will have same dimensions. Kindly observe this. Next one. Let us consider, it is advanced 2019 question. Let us consider a system of units which mass and angular momentum are dimensionless. Observe this carefully. Mass is dimensionless, angular momentum is dimensionless. If length has a dimension L, which of the following statements are correct? It is more than one option. We can check that now. First, I am going to write angular momentum. Let us consider angular momentum. Small l I am representing. Reason is length they have mentioned in L. That's why small l is equal to. I can write it as m into v into r. Okay. That L can be written as dimension of L is m lt power minus 1 L. That is equal to m L square divided by the t. For our reference purpose, I am writing this. Given that L is dimensionless, similarly, mass is the no. This is a mass, dimensionless. Mass is dimensionless. If mass is dimensionless and L is dimensionless, so we can write it as t, dimension of t is equal to dimension of L square. Observe this carefully. Dimension of t is equal to dimension of L square for this question. Now you can see dimension of force is equal to how much? You can write dimension of force. First you check that. Dimension of force. F is equal to, you can write ml t power minus 2. That is ml divided by the t square. M is dimensionless. L is dimension is L only. T square is dimensionless. Dimension is how much here? L square. If you bring this one, you will get the L power minus 3. Means as per the question, this is correct. Dimension of power. P is equal to, you can write it as energy by time. ml square t power minus 2 divided by the t. ml square t power minus 3. That is ml square divided by the t cube. M is dimensionless. You can write it as L square divided by the T cube. L square is L square only. T, what is the T dimension? L square is there. You can write it as T cube is nothing but L to the power of 6 you will write. Okay, you can write T square is equal to, T cube is equal to L power 6. So can write L to the power of minus 4 you will get power. Okay, so this is wrong. Next, dimension of linear momentum. Dimension of linear momentum. Dimension of linear momentum. Linear momentum can be written as P is equal to, dimension is directly related. Dimension of linear momentum is, you know that m L t power minus 1. So we can write it as m L divided by the t. M is dimensionless as per the question. So you can write it as L divided by the L square, that is equal to L power minus 1. Why I am writing L square here? T dimension is L square. That's why I am writing L square. So L power minus 1 is there. So that also correct. Next, the dimension of energy is L power minus 2. I am writing energy. Dimension of energy. M, that is m L square t power minus 2. M L square divided by the t square. It is dimensionless. So you can write L square divided by the t square. That is L square divided by the, again you can write L to the power of 4. Reason is dimension of t is L square. No, you can write it as L square by L to the power of 4 is L to the power of minus 2. You can write L to the power of minus 2. That also correct. So options are A, C, D are correct options. Observe this carefully. They are asking in JEE Advanced the basic questions only. Next, you observe that in 2020 they asked one more question. Sometimes it is convenient to construct a system of units so that all quantities can be expressed in terms of only one physical quantity. In one such system, dimensions of different quantities are given in terms of quantity x. They have given like this. I am writing here. Position means L dimension they are I am writing L dimension they are representing with x power alpha. I am not writing square bracket, just I am writing speed. Speed is L t power minus 1 is x power beta. Acceleration, L t power minus 2 is the dimension of acceleration, that they have represented with x power p. Linear momentum, you can write m L t power minus 1, that is x power q. Linear momentum dimension is the that I am writing. Okay. Force, force dimension is m L t power minus 2 is equal to they have representing with x power r. Now we need to write the relation between alpha, beta, p, q, r. For that I am taking one by one. First option I am going to take alpha plus p is equal to 2 beta. I am checking now. First option whether it is satisfied or not I am checking. For that what I am taking is just multiply the alpha term and beta term. Alpha term and p term. X power alpha into x power p is equal to x power alpha plus p. If I write the x power alpha value, x power alpha is L, x power p value is equal to, you can see L t power minus 2, that is x power alpha plus p. L square t power minus 2 is equal to x power alpha plus p. We can write L t power minus 1 whole square is equal to x power alpha plus p. So we can write x L t power minus 1 is nothing but x power beta only now. So you can write x power 2 beta is equal to x power alpha plus p. So from this you can write it as alpha plus p is equal to 2 beta. First option is correct option. Similarly, you can check the remaining thing. Let us consider the second option B. P plus Q minus R is equal to beta they are asking. Whether we are getting beta or not I am checking now. First P. Where is x power P? X power P into x power q into x power minus r value I am writing. X power p plus q minus r will write. Okay, x power p is nothing but l t power minus 2 q m l t power minus 1. Next, x power minus r we have to write now, m l t power minus 2 whole power minus 1 is equal to x power p plus q minus r. Now you can write it as L t power minus 2, M L t power minus 1, M power minus 1, L power minus 1, t power plus 2 is equal to x power p plus q minus r. First m terms is here. M power 1, no, M power minus 1 get cancelled. And similarly, L and L power minus 1 get cancelled. So finally 1L is there. T power minus 2 and T power plus 2 get cancelled. So we can write it as L T power minus 1 is equal to x power p plus q minus r is there. So from this you can write it as what is the meaning of LT power minus 1? LT power minus 1 is x power p plus q minus r. You check that where is the x power p is there, x power beta is there. Okay, sorry, LT power minus 1 is x power beta is equal to x power p plus q minus r. So beta value is equal to p plus q minus r. So it is also matching. So you can write the B option is correct. Next one, p minus q plus r is equal to alpha. So C option, p minus q plus r. Minus q plus r is equal to alpha. I am checking that. X power p, x power minus q, x power r is equal to x power p minus q plus r. If you write the p value, L t power minus 2, q value m power minus q, I am substituting, already I have written. Now you can also check that. L power minus 1, t power 1, x power r m l t power minus 2 is equal to x power p minus q plus r. So if you write the values, you can see that m and m power minus 1 get cancelled. So you can write L power minus 1 and L get cancelled, t power minus 2 and this value will get the t power minus 2 and t is a t power minus 3 you will get. That is equal to x power anything is there, L also there. L t power minus 3 is equal to x power p minus q plus r. LT power minus 3, where is there LT power minus 3? LT power minus 1 is there, LT power minus 3 is not there, so C option is wrong option. Okay, next similarly p plus q plus r is equal to beta. So from this what you write? Alpha is not equal to p minus q plus r. D option. D option, p plus q plus r is equal to beta. Okay, you can write x power p, x power q, x power r is equal to x power p plus q plus r. You check that L t power minus 2, m L t power minus 1, q is ml t power minus 1, r is m L t power minus 2 is equal to x power p plus q plus r. You can see m is not getting cancelled anywhere, so you can write m square. L is not getting cancelled anywhere, L cube, and you can write the R is nothing but force, no, MLT minus 2, correct only. So you can write ML cube and T power minus 2 minus 2 minus 5. You can get the x power P plus Q plus R. Beta value means you should not get the M term. Okay, beta value you check that M term should not be there. So we can P plus Q plus R not equal to beta. So from this A and B are correct options. Answer is A comma B is correct answer. Okay. Next, in advanced 2013 paper 2, they have asked like a Boltzmann constant. List 1, list 2 questions are there. Boltzmann constant. What is a Boltzmann constant? We can write energy is equal to K into T. Boltzmann constant into T. So Boltzmann constant is energy divided by the temperature. Okay, energy divided by the temperature. What is energy? M L square T power minus 2, dimension I am writing, dimension of kV. Temperature is K. So we can write m L square t power minus 2 k power minus 1. Anywhere ml square t power minus 2 k power minus 1. So Boltzmann constant is matching with the fourth option. Here two options are there. Check the next coefficient of viscosity. Already you have seen that earlier. Coefficient of viscosity, dimension of eta is equal to pressure into time. Pressure is m L power minus 1 t power minus 2. Time is t, that is m L power minus 1 t power minus 1. So you can write L power minus 1 t power minus 1. So second one is matching with the second one. Planck's constant, already you have written this ml square t power minus, anyway you got the answer is C option here. Okay, Planck's constant ml square t power minus 1. And thermal conductivity, that also earlier I have given, you can also try that. Okay, fourth option, third option is the correct option. Next, in 2023, same kind of question they asked in 21, 22, 23, 24 also. Young's modulus. What is Young's modulus? Young's modulus, Y is nothing but force per unit area divided by the delta L by L. It is dimensionless. Dimension is pressure actually here. M L power minus 1 t power minus 2. You can see m L power minus 1 t power minus 2. It is matching with third one. Coefficient of viscosity. Coefficient of viscosity also just now I have given. We can see here also I have given ml minus 1 t power minus 1. Planck's constant ml square t power minus 2. Work function. I have taken actually this question to write the work function. Okay, work function is nothing but energy only. Minimum energy required to eject the electron from the any metal surface is work function. Now that this is ml square t power minus 2. Okay, ml square t power minus 2. Okay, next in 2024 9th April they asked one question. What is the latent heat? Actually I have given earlier, they asked separately. That's why I'm telling, don't remember any formula, just observe this. This is my last question. You can see latent heat, you can write Q is equal to m into L. Q is energy, m is mass, L is latent heat. You should have the first relation. Okay, dimension of L is equal to Q divided by the m. Q is nothing but m L square t power minus 2 divided by the mass is m. M and m get cancelled. Finally, we will get L square t power minus 2. M is not there, that's why I am writing m power 0. So which option following is correct? M power 0 L square t power minus 2. This is the correct option. Kindly go through that. I have tried to give the to cover a maximum number of dimensional formulas. Through this I have given approximately, I think 19 to 20 questions I have pasted here from the previous JEE mains and 2-3 questions from the JEE advance also. Okay, I have given the information only how to write the dimension formula of different physical quantities, that's all. I have not written that what is the relation among the different physical quantities, like correct relations. Okay, like F is equal to mv square by r. That kind of relations I have not written. In the next case, I will next lecture I will explain like what are the applications of the dimensional analysis. I have not done any analysis till now, just I have given the dimensional formulas only. I hope everyone got this. You can also try the PYQ questions. Mostly they are giving same kind of questions in JEE Advanced, JEE Mains or any other engineering exams.